Welcome back to the deep dive. Today we're tackling a big one, a real logistical headache for system operators. How do you get multiple satellite TV signals into, say, an apartment building or a hotel without running a ton of copper cable?
Right, without running 6 separate cables all the way through the building. It's a nightmare.
Exactly. So our mission today is to understand the technical fix for this. The Thor Broadcast F-LB61-CWRX optical receiver.
And this thing is, well, it's the key. It's the shortcut that lets you carry all those L-band signals on just one single strand of fiber optic cable.
One strand.
It's fascinating because it just completely solves that core distribution problem.
Yeah.
L-band RF signals, the actual signal from the satellite dish, they're really hard to move over long distances with old school coax
Enough signal loss, right?
Yeah.
Attenuation.
Way too much. So this receiver just sits at the other end and gives you 6 standard L-band outputs. You plug those right into a normal multi-switch in the building, and you're done.
So it's receiving a signal that was all bundled up by its partner, the FLD61-CWTX transmitter.
Exactly. It's the final step.
Okay, so the magic here is obviously in the bundling. I mean, 6 separate channels.
Yeah.
How does one tiny piece of glass handle all that? It sounds impossible.
Well, that's where the acronym comes in. It's called Coarse Wavelength Division Multiplexing, CWDM.
CWDM, okay.
Think of it like this. Instead of sending data using just one color of light, the transmitter sends out 6 different colors or wavelengths all at the same time.
Like a rainbow down the fiber.
Basically, yeah. And this receiver has 6 little receivers inside it, each with a special filter that's tuned to look for just one of those colors. It picks its color out of the rainbow and ignores the rest.
And that's how it separates the channels back out again.
That's it. That's how you get 6 discrete channels from that single piece of glass.
That is really elegant. Now, the documentation calls this ideal for mid-scale systems. My mind immediately goes to DWDM, the dense version that can handle way more channels. Why not just use that?
It's all about scale versus cost and complexity. I mean, this CWDM setup is so much simpler and, frankly, cheaper than a full DWDM system or needing EDFA amplifiers to boost the signal.
So it hits a sweet spot.
It really does. And the scaling is still pretty impressive. A single transmitter can drive up to 32 of these receivers.
32. Wow. So that's 32 different apartment buildings or locations.
All running off one central fiber link. You only start thinking about those bigger, more expensive systems when you need to go beyond that.
And this isn't some niche piece of hardware either. The sources say it's compatible with pretty much every satellite TV provider in the world.
Yeah, you're not locked into one vendor, which is huge. But if we're talking about real-world use, we have to talk about the receiver's sensitivity.
Okay, what do you mean by that?
It's about how much abuse the fiber link can take before the signal drops. The spec sheet says its sensitivity is -9 dBm, but the notes highlight it can actually work all the way down to -12 dBm.
And for an installer in the field, what does that extra margin actually mean?
It means forgiveness. A typical receiver might die at benign to 7 dBAP. This extra 5 dBAP of margin means it can handle dirty connectors, a bad splice, maybe too many bends in the fiber.
Real-world problems.
Exactly. That 5 dB difference is like adding almost 15 kilometers of extra fiber distance. It's the gap between a perfect lab setup and a messy wiring closet on a Tuesday.
So you spend less time troubleshooting the link and more time getting customers online.
That's the idea. And to just, nail down the specs.
Yeah.
The frequency range is 45 to 3,000 megahertz, so it covers the whole L-band. It uses those 6 CWDM optics we talked about, and it sips power less than 25 watts.
And physically, it's just a small box you can tuck away, uses those standard SKPC connectors. 1 fiber in, 6 coast cables out, clean.
But here's where it gets even more flexible. You don't just have to do one transmitter to one receiver. You can use something called a PLC splitter.
I'm passive splitter.
Yes, a planar light wave circuit splitter. It's a cheap, passive device that lets you split that one optical signal into multiple paths. So your single fiber can feed a bunch of these receivers within the same large complex.
Ah, so it's not just point-to-point, it's point-to-multipoint.
Immense scalability, all passive.
So to bring it all home for you, what we've seen in this deep dive is how this specialized hardware, the Thor F-LB61-CWRX, uses CWDM technology to solve a massive cabling problem. It takes these complex satellite signals and makes them easy and efficient to transport over huge distances on a single fiber.
Precisely. And that leads to the real question to think about. If one fiber can carry 6 channels and you can passively split that optical signal multiple times with cheap PLC splitters, how does that change the entire economic model for wiring a new high-density building compared to the old way of pulling kilometers of heavy, expensive copper cope?